All right, we are in section 8.4 where we're going to multiply and divide rational expressions. Again, when we multiply and divide, our goal is to get it into its simplest form. And the simplest form means is that in a rational expression, it has no common factors other than plus or minus 1 in the numerator and the denominator. So for the most part, multiplication is fairly easy because you just multiply the numerators across and the denominators across. But what we like to do in this section is sometimes even before we multiply or divide, I want to see if I can factor out the numerator and denominator and cancel things out before we even um, reach the multiplication or division operation. So when I look at examples A and B, all we're doing is I want to get that fraction into its simplest form. So I look at the numerator, and I have x squared minus 81. And as I look at that, I can factor that because that is this the sum and difference pattern where I can go parentheses, parentheses, and this look at x plus 9 and x minus 9. X plus 9 times going to x minus 9 is exactly the same thing as writing x squared minus 81. And if I were to divide, I can factor out my denominator too. So I got x here, x here. The negative 36 tells me that both signs are going to be different. And then I need to assign something that's difference is 5, but product is 36. And that's going to give me a plus 9 and a minus 4. So now that I look, I have a x plus 9 in the numerator and an x plus 9 in the denominator. Both are concealed through parentheses, and since they had the parentheses, I can cross those out because basically what that is that's going to give me 1. Whatever number that x is going to be, like say if x was 1, I would have 10 divided by 10, which makes 1. And so anything multiplied by 1 is going to be itself. It's the identity. So I just cross those out, representing those as 1. So at the end of this, I can take it as x minus 9 divided by x minus 4. And that is in its simplest form. So if I look at B, when I look at factoring that, I can factor out a 4x in the numerator. And then in the parentheses, it'll end up being x plus 5 divided by, I can factor out a 2 here, so I got 2, and I can also factor out an x. So then, and then parentheses is going to be 3x squared plus 16x plus 5. So from here, what I'm going to do is I'm just going to move that down because I can factor this out even further. This is a prime number, so I can just say 3x and x. This plus sign tells me that the signs inside them are going to be the same. That plus sign tells me they're both going to be positive. And then I need to find something that's going to be, when we add these all together, it's going to give me a 16x, but the products are 5, and it's going to be a 3x plus 1 and an x plus 5. And see here I have an x plus 5 in the numerator, x plus 5 in the denominator. And then I have 4x divided by 2x. So this gets crossed out, this gets crossed out, and 4 divided by 2 will give me a 2 in the numerator, divided by, this will get crossed out, and it'll just leave me with 3x plus 1. So that's the way we simplify them. So now we're going to go and use multiplication. Initially, for these two fractions, I can't factor anything out. So the best thing to do is just multiply across and then simplify later. So 5 times 27, I'm dealing with the numbers, that'll give me a 135. I got x to the second times x to the fifth, so that's going to give me an x to the seventh. And then I have just the y to the third. Divided by 3 times 15 is going to give me a 45. X times x to the fourth is going to give me x to the fifth. And then y to the fourth times y is going to be y to the fifth. And then this is going to equal, if I take 135 divided by 45, will give me 3. If I go x to the seventh divided by x to the fifth, it's going to give me x squared. And then y to the third divided by y to the fifth is going to give me a y to the negative second. But I want to make that positive, so I'm going to put the y in the denominator. And that is in its simplest form. So now for b, I have 20x minus 5x squared divided by x squared minus x multiplied by x squared plus 3x minus 4, all divided by x squared minus 16. So before I multiply, let's see if I can factor things out. So for first off, I can take out a 5x in this numerator here, which will leave me with 4 minus x here divided by, I can take out an x in the denominator here, so it leaves me with x minus 1 multiplied by, I can factor this out using reverse FOIL. I got x here and x here. And this will give me a plus 4, a minus 1, divided by, and this is the sum and difference pattern, which tells me that this could be written as x plus 4 divided by x minus 4. So I can cancel some things out. So I got the x minus 1, x minus 1, x plus 4, x plus 4, x and x. And right now, we'll just leave it as that. So right now I have 5 in quantity 4 minus x divided by x minus 4. So these two here look very close. So what I want to do is all I'm going to do is just flip the x and the 4 around. I'm not doing any changing of signs quite yet. So I'm going to go 5 times a negative x plus 4 divided by x minus 4. Haven't done any changing of signs yet. Now I'm going to take out a negative 1 inside that parentheses. So now I got negative 5 times the quantity x minus 4 divided by x minus 4. Now I can cancel these out, which just leaves me with the value of negative 5. Okay? Here I have multiplying rational expression just by a polynomial. So all we're going to do here is we're just going to attach a 1 to it. So it looks like a fraction. So first off, I have x minus 4. Can't do anything else with that. Now if I look at this one looks like the sum of two cubes. Now if you remember in earlier sections, the sum of two cubes are if I have an a cubed plus b cubed, this equals, in parentheses, a plus b times the quantity a squared minus ab plus b squared. So let's write that out. So in this case, my a is going to be x and my b is going to be 2 because 2 cubed is 8. So in the bottom here, I'm going to write x plus 2 times the quantity x squared minus 2x plus 4, all of which is multiplied by x squared minus 2x plus 4, all over 1. And you look at it, this is the same and that's the same, so I can cancel those out. Now I'm left with x minus 4 divided by x plus 2. Okay. The next one. first off, I can't do anything with this numerator here. I can use reverse FOIL for my denominator. So I got x and x plus minus, and this is going to be a 5 and a 12 multiplied by, I got x squared plus 11x. I can factor out an x here, so here I can cancel this and that, and that's it. So if I multiply this across, I'm left with x times quantity x plus 11, all of which is divided by x minus 12. Next off is we're dividing rational expressions. When dividing, it's the exact same thing as multiplying. You're still going to multiply, but except you're going to multiply that second value by its reciprocal. So if I have 3x cubed y to the fourth z to the second divided by 5, all of which is divided by 27 y to the sixth z to the seventh divided by 15x squared y, you're actually going to go, you're going to keep the first value the same. We're going to go 3x cubed y to the fourth z squared divided by 5. Then we're going to multiply by its reciprocal. So I'm going to go 15x squared y divided by 27 y to the sixth z to the seventh. And then I can multiply this out. So if I have 3 times 15, it's going to give me a 45. I have x cubed multiplied by x squared, that's going to give me x to the fifth. Y to the fourth multiplied by y is going to give me y to the fifth. Z squared, and that's it. So I'm just going to write z squared divided by 135 here, and it'll just be y to the sixth, z to the seventh. So 45 divided by 135 is going to give me a 1/3, so I'm just going to leave a 3 on the bottom. I'm not going to write the 1 just yet. I have x to the fifth, and I have nothing in the denominator with an x, so I just leave that as is. I have y to the fifth, z to the sixth, which is going to give me y to the -1, so I'm just going to make it positive right now and put it in the denominator. Then I have z to the second. That should be the second. I don't know why I have 6 there. Z to the second divided by z to the seventh will give me a z to the -5, so I'm just going to write z to the fifth in the denominator to keep it positive. And that's what it looks like in simplest form. Let's look at B. So what I'm going to do is, again, we're going to write this as a reciprocal. So I got x squared minus 4x minus 21 divided by 5x plus 15 multiplied by x squared minus 100 divided by x squared plus 3x minus 70. So I can reverse FOIL this numerator here, which will give me x plus 3 and x minus 7, all divided by, I can factor out a 5 here, so then that leaves me with x plus 3 in the bottom. Multiply this numerator here is the sum and difference of x plus 10, x minus 10, and then the bottom one I can factor out using reverse FOIL, so then I got x and x. It's going to give me a plus 10 here and a minus 7 here. So let's take a look. I can cancel this, I cancel that, here, and here, and here, and also here. So I'm left with x minus 10 in the numerator divided by 5. Okay. Last one that we're going to do is being able to divide rational expressions by a polynomial. So we have a fraction in that first position divided by something that's not a fraction, but technically it's divided by 1. So when we take the reciprocal of it, so it'll be 3x squared plus 13x minus 10, all divided by 6x squared. We're going to multiply it by 1 divided by 3x squared minus 2x. So this first numerator, I can factor it out using reverse FOIL, and it's going to be 3x minus 2 and x plus 5 divided by 6x squared. Multiply by 1 divided by, I can factor out an x here, which then will give me 3x minus 2. And I can cancel out this one and this one. And I'm left with x plus 5 on the top and 6x cubed on the bottom. Okay. Last one. I have I have x cubed minus 64 divided by 15, all of which is divided by x squared plus x minus 20. Now, if you look at, let's just rewrite this. I'm going to go x cubed minus 64 divided by 15, multiplied by 1 divided by x squared plus x minus 20. So this one here looks like the difference of two cubes. And if we remember, we got a cubed minus b cubed ends up equaling a minus b times the quantity a squared plus ab plus b squared. So this can be written as x minus 4, because 4 cubed gives me 64, multiplied by, this would be x squared plus 4x plus 16 divided by 15, multiplied by 1 over, and this can be reverse foiled. We got x, this will be plus and minus. This will be a 5, and this will be a 4. Cancel out this, and can't cancel anything else out, so I'm just left with x squared plus 4x plus 16, all divided by 15 times x plus 5. Okay. And that is being able to multiply and divide rational expressions. Hope this helps. Till next time.